For this video, we will continue with Module 3 in Geometric Design of Highways and Railroads. This is Unit 5 about intersection site distance. We have discussed about the decision site distance in Unit 4 and the stopping site distance in Unit 3. So, for this unit, the desired learning outcomes is to determine the intersection site distances. So what is intersection site distance? From the word itself, it is the site distance that is provided for intersection so that drivers will be able to have more time in decision or in the decision process making. They will have more time, or they will be allotted more distance in deciding on what proper maneuver will they do when they are encountering a certain intersection, because some intersections, they are not controlled by traffic devices. Some of them are uncontrolled by traffic devices, such as the traffic lights. So we have mentioned in the decision site distance that we provide this decision site distance for some areas, and one of these areas, or one of these road portions wherein we provide decision site distance is the intersection. So here we will be discussing in detail more about the intersection site distance. All of the details here are provided by the Ashton Green Book 2011, page 9, or chapter 9, page 28. Each intersection has the potential for several types of vehicular conflicts. Of course, there are different types of maneuvers that a driver may do when he or she will be able to meet a certain intersection. There are also a lot of elements, traffic elements, pedestrians, that may contribute to the traffic noise that we call. So we need to provide intersection site distance. Possibility of this conflicting occurring can be greatly reduced through the provision of proper site distances. That's what I've mentioned, these intersection site distances, and the appropriate traffic controls. Traffic controls are some road elements, and traffic lights are included in these traffic controls. But there are some intersections, especially in rural areas, that we don't provide traffic control devices because the demand or the number of vehicles that is passing through it are not that much as compared with urban road intersections. So some roads or some intersections do not have appropriate traffic controls. We will tackle them later. The avoidance of conflicts and the efficiency of traffic operations still depend on the judgment, capabilities, and response of each individual drivers. Of course, even if you provide traffic controls and proper site distances, if the driver will not, as we have mentioned during our previous discussions, that each driver has different capabilities. They have different judgment. They have different perception reaction times. So it is still depending on the capability of drivers. So in the geometric design, considering intersection site distance, we consider always the majority of the drivers. All of these values that we provide are based on certain researches of different driver behaviors, because it will be these drivers that will be using the roads. Of course, we should cater the design of this road intersection to the users, which is the drivers in this case. So continuing, stopping site distance in our unit 3 of this module is provided continuously along each highway or street so that drivers have a view of the roadway ahead that is sufficient to allow drivers to stop. So along the length of the roads, we always provide stopping sight distances. Even if there is an intersection, there is still a provision of intersection sight or stopping sight distance in this case. It's continuously provided. Okay, let me underline this one. Okay, the provision of stopping sight distance at all locations along each highway or street, including intersection approaches, is fundamental to intersection operation. Vehicles are assigned the right of way at intersections by traffic control devices or where no traffic control devices are present by the rules of the road. So I have mentioned not all of the intersections have traffic control devices. So we give the right of way to vehicles by providing traffic control devices or by using the rules of the roads. Of course, that is an intersection. There are four vehicle sources that may enter the intersection. So some may come from here, going to that direction. Some may come here, some here, and some here. Although there are also three-way intersections, but the most common are four-way intersections. So there are a lot of vehicles that may pass it, and to determine the right of way, meaning to determine which vehicles will be using that intersection in that period of time, we provide traffic control devices or simply the rules of the road, especially for intersections with no traffic control devices. So what is this rule? The basic rule of the road at an intersection where no traffic control devices are present requires the vehicle on the left to yield to the vehicle on the right if they arrive at approximately the same time. So this is very common in the rural areas of the Philippines or even in other parts of the world. Tagalog, this is called bigayan. So especially in places that there are no traffic control devices or intersections with no traffic control devices. Sight distance is provided at intersections to allow drivers to perceive the presence of potentially conflicting vehicles. So, similar to the previous statement, so to prevent potentially conflicting vehicles, we provide a right of ways to intersections through traffic control devices. And through, of course, the provision of sight distances, specifically intersection sight distance. This should occur in sufficient time for a motorist to stop or adjust their speed as appropriate to avoid colliding in the intersection. So as I have told you, we provide sufficient time for the drivers, or what we also call motorists, to decide on which necessary maneuver is appropriate in a specific situation in an intersection. The methods for determining the sight distances needed by drivers approaching intersections are based on the same principles as stopping sight distance, but incorporate modified assumptions based on observed driver behavior at intersections. So all of the different sight distances are basically based on the ideas of the stopping sight distances. Continuing, the driver of a vehicle approaching an intersection should have an unobstructed view of the entire intersection, including any traffic control devices, and sufficient lengths along the intersecting highway to permit the driver to anticipate and avoid potential collisions. That is self-explanatory. The sight distance needed under various assumptions of physical conditions and driver behavior is directly related to vehicle speeds and to the resultant distances traversed during perception reaction time and braking. So similar to stopping sight distances or all of the sight distances, we base it on physical conditions and driver behavior, and we relate it to vehicle speeds. Of course, different design speeds will need to have a different provision of this sight distances. General rule is that if there is more uh, the if the driver or the vehicle is moving at a larger or higher speed, of course there is more distance that should be provided, more sight distance that should be provided. That is why one way to prevent accidents, if there is no if the provision of this relatively long sight distances is not applicable, we limit the distance or the speed in these road sections. Sight distance is also provided at intersections to allow the drivers of stopped vehicles a sufficient view of the intersecting highway to decide when to enter the intersecting highway or to cross it. If the available sight distance for an entering or crossing vehicle is at least equal to the appropriate stopping sight distance for the major road, then the drivers have sufficient sight distance to anticipate and avoid collisions. So later we will be discussing two types of sights. We call them sight triangles that will be provided. One is the approaching, that is when the driver will be approaching the intersection and it is not yet on the edge of this intersection. And another is a departure that is provided when the driver is on the stop, the vehicle is stopped on the edge of this intersection. Departure and approaching sight triangles. We will go over it later in this video. However, in some cases, a major road vehicle may need to stop or slow to accommodate the maneuver by a minor road vehicle. To enhance traffic operations, intersection sight distances that exceed stopping sight distances are desirable along the major road. Specified areas along intersection approach legs and across their included corners should be clear of obstructions that might block a driver's view of potentially conflicting vehicles. So we are now going to discuss about sight triangles. In this image here that is on the slide, you may notice this taxi, or let's assume that you are here in this portion. Let's assume that you are a taxi driver that is in this portion of the road. So the critical areas that you need to see are, of course, for the roads in the Philippines or even in America, we always keep right? So if this vehicle or this taxi, for example, will go on this portion of the road here on its right, of course, what this driver needs to see or need to have a view of is this area. If there is an approaching vehicle that will move in the same direction that he is going into, okay, the driver is going here on its right and he needs to see if there is a coming vehicle on this portion that will pass or go in the same direction. So from here, from this driver going straight, and on this portion he needs to have a clear view, and we call that a sight triangle. Later we will have a different image that will show it on top view for us to be able to see it clearly. But I guess you have an idea of what are the different angles that the driver needs to have a view of whenever he will do a certain maneuver. These specified areas are known as clear sight triangles. The dimensions of the legs of the sight triangles depend on the design, speeds of the intersecting roadways, and the type of traffic control used at the intersection. Of course, sight triangles should be considered, especially in intersections wherein no traffic control devices are provided, because in that case, the driver behavior or the decision or the judgment of the driver will be the determining factor on whether he will meet an accident or not. These dimensions are based on observed driver behavior and are documented by space-time profiles and speed choices of drivers on intersection approaches. So, as I have mentioned, these are based on driver behavior and they documented it on space-time graphs. Two types of clear sight triangles are considered in intersection design. The first one is the approach sight triangles, and the second is the departure sight triangles. So we'll be going over these two types of clear sight triangles in the next slides. We'll start with the approach sight triangles. So this image here was taken from the Ashton Green book 2011. This is figure 9-15A. Approach sight triangles, uncontrolled or yield control. So we have here this intersection, as I have mentioned a while ago. We have here approach sight triangle for viewing traffic approaching the minor road from the left. So this is where the driver will come from. Okay? Of course, he will go in this direction. And he wants to go from the left going to this part. Okay, he wants to turn here. So what he needs to have is this clear sight triangle. There should be no obstructions in these portions for him to be able to see these parts. And for this one, this portion here, the driver is here. We have the decision point. That is where the driver will start seeing, or he will start to decide on which maneuver to do. Will he continue to turn on his desired direction, or will he stop at the edge of this intersection? So for this part, from the right, the driver will continue and he will turn here. Okay, so that is approach sight triangles. Each quadrant of an intersection should contain a triangular area free of obstruction that might block an approaching driver's view of potentially conflicting vehicles. So similar to the x and y axis, we have your intersection here and we divide it into quadrants. So this is 1, 2, 3, 4 quadrants. So all of these quadrants should be provided with an appropriate approach sight triangles or sight triangles in general. The length of the legs of this triangular area along both intersecting roadways should be such that the drivers can see potentially conflicting vehicles in sufficient time to slow or stop before colliding within the intersection. The figure shows typical clear sight triangles to the left and to the right for a vehicle approaching an uncontrolled or yield-controlled intersection. When you say uncontrolled or yield-controlled, meaning there are no traffic lights or traffic control devices that are provided. It depends on the judgment of the drivers that is passing through these intersections. So the vertex of the sight triangles on the minor road, here is the minor road, because that is where the driver will be coming from. The major road is where he will be crossing. Okay? or an uncontrolled approach represents the decision point for the minor road driver. So I have placed the driver here a while ago. The minor road is in this portion. This decision point is the location at which the minor road driver should begin to brake to a stop if another vehicle is present or an intersecting approach. So that is the decision point. That is where the driver should decide on which maneuver should he do. Will he continue to do the maneuver of going to the right or to the left, whichever, or crossing the intersection, or will he stop if he perceives an approaching vehicle in his way? The distance from the major road along the minor road is illustrated by the distance a sub 1. So that is distance from the major road along the minor road on which he is going. A to the left, A1 to the left, and A2 to the right. So if the driver will be viewing traffic for those vehicles approaching the minor road, this is the minor road. Vehicles approaching the minor road from the left are those that are coming from here. So he needs to see these vehicles. Okay? And that distance from that major road is to the decision point is what we call a sub 1. For the decision point in the other type, this is a sub 2. Of course, a sub 2 is longer as compared with a sub 1. This type of approach side triangles, remember, is only applicable for road types wherein we practice maintaining or going to the right always, or keeping right. Distance a sub 2 is equal to distance a sub 1, as shown in the figure, plus the width of the lane or the lanes departing from the intersection on the major road to the right. Distance a sub 2 should also include the width of any median present on the major road unless the median is wide enough to permit a vehicle to stop before entering or crossing the roadway beyond the median. These medians are areas or the divisions between these highways. Some medians are wide enough to permit a vehicle to stop at the middle of this road. Okay, for example, if the driver will be going to this direction, to the left, the driver may opt to stop at the middle of this road if he perceives a vehicle that will pass through this major road straight, if the vehicle from this portion will pass through this one, another vehicle, let me just change. For example, this is the vehicle, and he will opt to stop on this portion to give way to this vehicle before continuing, and at such time that the red vehicle will be passing through the major road, he will be continuing his maneuver. Okay, so that is if the median, this median part, is wide enough to permit this green vehicle to stop before proceeding with the maneuver. But of course, if that is not that wide, you should consider it, and the safest thing to do is to stop at the edge of this intersection in the minor road before proceeding with your maneuver. The geometry of a clear side triangle is such that when the driver of a vehicle without the right of way sees a vehicle that has the right of way on an intersecting approach, the driver of that potentially conflicting vehicle can also see the first vehicle. So they will be able to see each other. Okay? If you are going to consider the driver that will be coming from this portion and he will be moving to this portion of the minor road, then you will need to provide another approach triangle. And of course, this distance will now be equal to a sub 1. And this distance will now be equal to b. This distance b is what we call your intersection side distance. Distance b illustrates the length of this leg of the side triangle. Thus, the provision of a clear sight triangle for vehicles without the right of way also permits the drivers of vehicles within the right of way to slow, stop, or avoid other vehicles if needed. Although desirable at higher volume intersections, approach sight triangles like those shown in the figure are not needed for intersection approaches controlled by stop signs or traffic signals. So we only provide approach sight triangles for those that has no traffic control devices such as traffic lights or traffic signals. In that case, the need for approaching vehicles to stop at the intersection is determined by the traffic control devices and not by the presence or absence of vehicles on the intersecting approaches. So if there is a traffic light installed within this intersection, and of course, the driver should follow it before proceeding with their maneuvers, because that will be the deciding factor on which vehicles or vehicle to give the right of way in that specific time period. We have the second type of the sight triangle or clear sight triangle. This is what we call our departure sight triangle. This provides sight distance sufficient for a stop driver on a minor road approach to depart from the intersection and enter or cross the major road. So this is departure sight triangle is provided when the driver is stopped on this portion and he is observing the other portions of the road if he will continue or postpone his maneuver. The figure shows typical departure sight triangles to the left and to the right or the location of a stopped vehicle on the minor road. So for the decision sight triangle, of course, that should have a smaller area, or yes, because the driver is stopping here. Okay, later we will discuss where will we get this a sub 1. Departure sight triangles should be provided in each quadrant of each intersection approach controlled by stop or yield signs. Departure sight triangles should also be provided for some signalized intersection approaches. See case D in section 9.5.3 on intersection control of AASHTO 2011 Clean Book. Later we will be discussing the several cases for intersection approaches. But this statement means that we provide departure sight triangles for uncontrolled, and of course they should be provided for controlled intersections, because if that is controlled, for example, if the traffic light directed the vehicles from here to stop, then they will have a mandatory stop, and that is where we provide departure sight triangles. Continuing, distance a sub 2 in the figure is equal to a sub 1 plus the width of the lanes departing from the intersection on the major road to the right, similar to our approaching sight triangles a sub 2. Already know that. It should also include the width of any median present on the road or the major road, unless the median is wide enough to permit a vehicle to stop before entering or crossing the roadway beyond the median. The appropriate measurement of distances A1 and A sub 2 for departure site triangles depends on the placement of any marked stop line that may be present and thus may vary with site-specific conditions. The recommended dimensions of the clear sight triangle for desirable traffic operations where stopped vehicles enter across or cross a major road are based on the assumptions derived from field observations of driver gap acceptance behavior. So again, they base this leg distances based on driver behavior. The provision of clear sight triangles like those shown in the figure also allows the drivers of vehicles on the major road to see any vehicles stopped on the minor road approach and to be prepared to slow or stop if needed. So we now move to intersection control. The recommended dimensions of the sight triangles vary with the type of traffic control used at an intersection because different types of control impose different legal constraints on drivers and therefore result in different driver behavior. So, as I have mentioned during our past discussion, the provision of traffic control devices, or in this case, the intersection control devices, will affect, of course, the behavior of our driver. It may affect the speed that they are using. It will affect the maneuver that they will do. Procedures to determine sight distances at intersections are presented below according to different types of traffic control as follows. So for case A, these are for intersections with no control. Case B, intersections with stop control on the minor road. So there is a stop control on the minor road. Stop control means stop sign on the minor road. Okay. There are three subdivisions of case B. B sub 1, left turn from the minor road. B sub 2, right turn. B sub 3, crossing maneuver from the minor road. Case C, intersection with yield control on the minor road. Yield control means a yield sign. When you say yield sign, the mandatory maneuver should be, or the maneuver should be based on yielding. You should evaluate first before proceeding with your maneuver. For the stop control, it means that you should stop, really stop. It is mandatory stopping. Two cases for case C, crossing maneuver from the minor road and left or right turn from the minor road. Case D is intersections with traffic signal control. This one is easier. Case E is intersection with always stop control, meaning there are stop controls or stop signs at each portions of the intersection. Case F, left turns from the major road. So let's start with case A, intersections with no control. For intersections not controlled by yield signs, stop signs, or traffic signals, the driver of a vehicle approaching an intersection should be able to see potentially conflicting vehicles in sufficient time to stop before reaching the intersection. The location of the decision point, or the driver's eye, of the sight triangles on each approach is determined from a model that is analogous to the stopping sight distance model with slightly different assumptions. While some perceptual tasks at intersections may need substantially less time, the detection and recognition of a vehicle that is substantial distance away on an intersecting approach and is near the limits of the driver's peripheral vision may take up to 2.5 seconds. So the perception time is similar to the stopping sight distance, 2.5 seconds. The distance to brake to a stop can be determined from the same braking coefficients used to determine stopping sight distance in Table 3-. 1. So we have discussed this table in the stopping sight distance. Field observations indicate that vehicles approaching uncontrolled intersections typically slow to approximately 50% of their mid-block running speed. This occurs even when no potentially conflicting vehicles are present. So for intersections with no control devices, it is studied that the normal approach of the driver should be to stop or at approximately 50% of their speed or reduce. Of course, the natural behavior of drivers will be to uh, reduce their speed to at about 50% of their original. Okay, so if the driver is originally uh, running at a speed of 30 kph prior to approaching the intersection with no control, there is no control, the natural ability or the natural behavior will be to reduce it to about 15 kph. This initial slowing typically occurs at deceleration rates up to 1.5 meters per second square. Deceleration at this gradual rate has been observed to begin even before a potentially conflicting vehicle comes into view. So even if they don't see any conflicting vehicle, they start with their deceleration. Of course, they are not sure on whether there is a possibility of a vehicle that is running at a relatively high speed that will cross the road that they are, the intersection that they are approaching. In that case, this is somewhat a factor of safety that the driver will give as a form of uh, accident reduction or accident avoidance. Braking at greater deceleration rates, which can approach those assumed in stopping sight distance, can begin up to 2.5 seconds after a vehicle on the intersecting approach comes into view. Thus, approaching vehicles may be traveling at less than their mid-block running speed during all or part of the perception reaction time and can therefore, where needed, brake to a stop from a speed less than the mid-block running speed. This table 9-3, which shows the distance traveled by an approaching vehicle during perception reaction time and braking time as a function of the design speed of the roadway on which the intersection approach is located. So for different design speeds of the roads, so this is the length of the legs for the sight triangles. For case A, where there is no traffic control, it shows the distance traveled by an approaching vehicle during perception reaction and braking time as a function of the design speed of the roadway on which the intersection approach is located. So again, we will use approach sight triangle because there is no traffic control devices that are installed in the intersection. These distances should be used as the legs of the sight triangle shown in figure 9-15A as dimensions A sub 1 and B. Distance A sub 2 is longer than distance A sub 1 as defined in discussion of approach sight triangles in the previous section or in the previous parts of this video. Referring to this figure, highway A with an assumed design speed of 80 kph and highway B with an assumed design speed of 50 kph need a clear sight triangle with legs extending at least 75 meters and 45 meters along highways A and B. So highway A has a design speed of 80 kph and highway B has 50 kph. So let's take a look at the table. Do we have it here? Yes, 75. 80 kph and 50 kph. 80, length of leg is 75. 50, length of leg is 45. Okay? This is the one that we will use for the distances A and B. This clear triangular area will permit the vehicles on either road to stop, if needed, before reaching the intersection. If the design speed of any approach is not known, it can be estimated by using the 85th percentile of the mid-block running speeds for that approach. So if there is no design speed for that specific road, if you're going to consider the intersection or side triangle, you will need to use the 85th percentile, similar to what we used in the other provisions of our designs. The distances shown in this table are generally less than the corresponding values for stopping sight distance for the same design speed. This relationship is illustrated in figure 9-16. So, this means that these values are lesser as compared with stopping sight distances. That is because the drivers are decelerating even if there is no approaching vehicle in the intersection. So that affects this provision. Where a clear sight triangle has legs that correspond to the stopping sight distances on the respective approaches, an even greater margin of efficient operation is provided. So if the stopping sight distance in that part is higher or lower, rather, because it says here, where a clear sight triangle has legs, these are the legs that correspond to stopping sight distances or relatively equal on the respective approaches, an even greater margin of efficient operation is provided, so that there is more factor of safety in that case if they will be near the stopping sight distance, because these are lower. This value are the minimum required length of leg. So if you will provide more, because stopping sight distances will have more comparing to their different design speeds, they will have more. The stopping sight distance will have more. Later we will show figure 9-16 to demonstrate that. So if you provide more distance, then that would be more efficient and more safer. However, since field observations show that motorists slow down to some extent on approaches to uncontrolled intersections, the provision of clear sight triangles with legs equal to the full stopping sight distances is not essential. So although the stopping sight distance is higher as compared with the legs of our sight triangle, because we know that according to studies and observations, the motorists slow down or decelerate to some extent at about 50% of their speed from their original speed. That is at about 1.5 meters per second squared. They decelerate at that rate. So it is not really essential to consider using the stopping sight distance as the legs of our sight triangles. So in this portion, you can see here, for case A or ISD, intersection sight distance legs with no traffic controls, they are shorter as compared with the sight distances. Here is the length of the sight triangle leg, and this is the design speed. So, mas malaki yung sight distances. Okay? Metric and US customary. Figure 9-16. So, table 9.2 4 is the adjustment factors for side triangles based on approach grade. Because if you will notice in our previous table here, table 9-3, for approach grades greater than 3%, multiply the side distance values in this table by the appropriate adjustment factor from table 9-4. If the grade is 2% or 2.99%, then you should use these values. But if the grade or approach grade of the road is higher, then you should adjust it by multiplying these values of the legs, length of legs, by the corresponding values in this table 9-4. So here, if you notice, for those approach grade, -3 to +3, you will multiply it by a factor of 1.0. You're not changing it. But if you will have a higher grade, of course, you will need to multiply it by these factors. If you will notice here in speeds, design speed 20 mph and 30 mph, you just multiply it by 1.0. Because you don't need to do much of the adjustments here, because that is small speed as compared with those speeds that are higher. You will need to multiply it by a certain factor, of course, that is higher. For downhill, the factors are higher because you will need to add to the leg, because we need to provide more distance. Because if you are going downhill, it is harder to decelerate as compared with if you're going uphill. You will have a lower factor here, less than 1, meaning you're decreasing the original design length of the leg. That is because if you're going up or uphill, then it is easier for you to decelerate. Okay? This is for US customary. The other one is for metric. Continuing, if the side distances given in table 9-3 as adjusted for grades cannot be provided, consideration should be given to installing regulatory speed signing to reduce speeds or installing stop signs on one or more approaches. No departure side triangle like that shown in figure 9-15b is needed at an uncontrolled intersection, because such intersections typically have very low traffic volumes. Okay, so yeah, we usually provide only approach side triangles, not departure side triangles, because if you will come to think of it, you will not provide traffic control devices for vehicles or intersections with less traffic volumes. We only provide those for those intersections in the urban roads or urban areas wherein there is really high traffic volume. If a motorist needs to stop at an uncontrolled intersection because of the presence of a conflicting vehicle on an intersecting approach, it is very unlikely another potentially conflicting vehicle will be encountered as the first vehicle departs the intersection, because there is low traffic volume. Kaya we don't provide control devices. Okay? So for case B, intersections with stop control on minor roads, departure side triangles for intersection with stop control on the minor road should be considered for 3 situations. Case B1, B2, and B3. Intersection side distance criteria for a stop controlled intersection are longer than stopping side distance. So a while ago, for case A, the length of the legs are lesser than stopping side distances. But for this one, these are stop controlled. We provide a longer length of the leg than stopping side distances to allow the intersection to operate smoothly. Minor road vehicle operations can wait until they can proceed safely without forcing a major road vehicle to stop. So let's start with case B1, or left turn from the minor road. So again, from this figure, consider this portion. This is the minor road, and you are going to the left to turn left. So let me draw some arrow. So for this case, let's say you have your car here. Departure side triangles for traffic approaching from either the right or the left, like those shown in figure 9-15b, that is this figure, should be provided for left turns from the minor road onto the major road for all stop controlled approaches. The length of the leg of the departure side triangle along the major road in both directions shown as distance b in the figure is the recommended intersection side distance for case B1. So this is the intersection side distance. The vertex or the decision point, this portion of the departure side triangle on the minor road should be 4.4 meters from the edge of the major road traveled way. So from this decision point up to this edge, that should be equal to 4.4. So let me put it here. This represents the typical position of the minor road driver's eye when a vehicle is stopped relatively close to the major road. So, where did that come from? Field observations of vehicle stopping positions found that where needed, drivers will stop with the front of their vehicles 2 meters or less from the edge of the major road traveled way. Measurements of passenger cars indicated that the distance from the front of the vehicle to the driver's eye for the current US passenger car population is nearly always 2.4 meter or less. So here in this figure, field observations have shown that drivers typically stop from this portion at the edge of the intersection in the major road up to the front or the tip of this car in the front, that is at about 2.0 meters or less, and from that tip up to the driver's eye, that is at about 2.4 meters or less. So adding them together, that will be equal to 4.4 meters, and that point, the driver's eye, is what we call our decision point. Okay, and sometimes it is provided with an additional of 1 meter, so that is at about 4.4 meters to 5.4 meters. This increase allows 3.0 meter from the edge of the major road traveled way to the front of the stopped vehicle, providing a larger side triangle. The length of the side triangle along the minor road is the sum of the distance from the major road plus 1/2 lane width for vehicles approaching from the left, or 1 1/2 lane widths for vehicles approaching from the right. So for this vehicle, if we will approach his left, okay, where is his left? His left will be here, right? Yes. If that would be his left, he will need to look at the vehicles on the right. Okay, so we will provide 1 1/2 the lane widths on the right for two lane highway, of course. So that is 4.4 plus 1 whole lane width plus 1/2 of this lane width. Okay, so that is distance A sub 2. So if he will go to the right or to the left or to the, wait, let me check this one. If he will go to his right, then of course he needs to look at his left. So that would be 4.4 plus 1/2 of this lane width. Okay? Again, this is the median that I was referring a while ago. The driver can stop at this portion. So these are the median roads or median of the roads that was discussed a while ago. So here, yun yung sinasabi ko kanina, from this portion up the driver's eye, that is about 2.4 meters. Field observations of the gaps in major road traffic actually accepted by drivers turning onto the major road have shown that the values in Table 9-5 provide sufficient time for the minor road vehicle to accelerate from a stop and to complete a left turn without unduly interfering with major road traffic operations. So these are the time gaps from the stop, the time of acceleration of the cars from the stop to complete its maneuver. For example, for this one, for him to be able to move from this one up to his for him to be able to complete this maneuver, he needs 7.5 meters or seconds rather from this table. For a passenger car, of course, that will be a different for single unit truck, and combination truck is provided for considering both of this one or different types of vehicles. The time gap acceptance time does not vary with approach speed on the major road. Studies have indicated that a constant value of time gap independent of approach speed can be used as a basis for intersection site distance determinations. Observations have also shown that major road drivers will reduce their speed to some extent when minor road vehicles turn onto the major road. So these values are not affected by the values or the design speed of the major road. When you say minor road, that is where the vehicle will move from. That is where the decision point is taken from. Major road is where the driver or the vehicle from the decision point will move to the left or to the right. So it can change. A minor road may be a major road for some point of view. Okay? Where the time gap acceptance values in Table 9-5 are used to determine the length of the leg of the departure site triangle, most major road drivers should not need to reduce speed to less than 70% of their initial speed. So when major road drivers see a minor road driver completing their maneuver at a period of 7.5 seconds, they naturally, observations tell us that they will stop at about or reduce their speed at about 70% of their initial speed. So that is why we provide stopping sight distance in these portions. Okay? Intersection sight distance for the minor road driver and stopping sight distance and decision sight distance for the major road driver in that case. The intersection sight distance in both directions should be equal to the distance traveled at the design speed of the major road during a period of time equal to the time gap. Okay? In applying Table 9-5, it can usually be assumed that the minor road vehicle is a passenger car. However, where substantial volumes of heavy vehicles enter the major road, such as from a ramp terminal, the use of tabulated values for a single unit or combination trucks should be considered, as shown here in the table. Table 9.5 includes appropriate adjustment to gap times for the number of lanes on the major road and for the approach grade of the minor road. So for multi-lane highways, we add 0.5 for passenger cars and 0.7 for trucks for each additional lane. For minor road approach grades, if the approach grade is on a upgrade that exceeds 3%, we add 2.2 seconds for each percent grade for left turns. Adjustment for the grade of the minor road approach is needed only if the rear wheels of the designed vehicle would be on an upgrade that exceeds 3% when the vehicle is at the stop line of the minor road approach. So here are the determination of the ISD, intersection sight distance, or the length of leg of the sight triangle along the major road. For case B, again, 0.278 is just a conversion factor from kph or kilometer per hour into meters per second. And ISD value here should be in meters. And of course, the time gap will be taken from table 9-5, and that should be in seconds, of course. We have here for metric and QS customary. V major is the design speed of the major road. The intersection sight distance along the major road is determined by this formula, and we have this example. Okay, for example, a passenger car turning left onto a two-lane major road should be provided sight distance equivalent to a time gap of 7.5 seconds in major road traffic. That is a passenger car, we should provide 7.5 seconds. If the design speed of the major road is 100 kph, we will have an ISD of 0.278, again the conversion factor, times 100, or the V major, times 7.5, or the time gap, and that would be equal to 208.5 meters. But we will round it up to 210 for design values. This is in meters. I forgot to place it in this slide. But for a passenger car turning left onto a 4-lane undivided roadway, we'll need to cross 2 near lanes rather than 1. So we will apply this part here. For multi-lane highways, we will add 0.5 seconds for passenger cars for each additional lane. So instead of, since that is a 4-lane undivided roadway, we added 1 passenger car. So let me draw that one. So this is a 4-lane highway. Vehicles are moving here to the right, and this is going to the left. So let's say the intersection is on this part. Okay. So that would be the original for 2-lane highway is that from this portion going to the left. Yes, so if the vehicle is here, it'll become here and here. For 2-lane highway, so imagine you don't have this portion. You will have this one, this maneuver. Because for 2-lane highway, this will become going to this part. Or let me just red draw it properly for you to be able to see it clearly. Let me use yellow. So for 2-lane highway, vehicles going in this direction and vehicles will be going on the other direction. If the car from here will move to the left, and he will follow this line, and he needs to move or pass through this one lane and one half of this, of course. So for 4-lane highways, let me draw it again. This is confusing. For 4-lane highways, vehicles are moving in this direction, and another here. Some are moving here, and some are moving here too. So this is the intersection. You have the vehicle here. They will move to the left. There's an additional 1 lane. Before, you are just considering 1 lane here. Now you added 1 lane. So for each additional lane that the vehicle is crossing from the left, then you will add 0.5 seconds for passenger car. That is why the time gap that is recommended will now be equal to 8.0. Corresponding value for sight distance leg, or the ISD, is equal to 2.4 or 223 rounded for the sign. This is in meters. If the minor road approach to such an intersection is located to a 4% upgrade, then the time gap selected for the intersection sight distance, the sign for left turn should be increased from 8.0 to 8.8 seconds, equivalent to an increase of 0.2 seconds for each percent grade. So, again, we are still considering the multi-lane, so the original one is 8.0. But then, that is a 4% upgrade. That is greater than 3%. So, we will add 4% here. Time gap will be equal to 8.0 plus 4% times 0.2 seconds per percent. Okay? So this will be equal to 8.8 seconds. Okay? ISD is now equal to 245 rounded for the sign. The design values for intersection sight distance for passenger cars are shown in table 9-6. Again, if you notice, the values here for the stopping sight distance are lesser than the values in the intersection sight distance for case B1. That is because there is a control measure or control device. So here are the figures that represents this table 9-6. Again, yeah, we have a larger value for the sight distances. Let me use another color because I think you cannot see it properly here. So yun yung for combination for trucks, and this is for the passenger cars. They are larger as compared with the SSD. Okay. No adjustment of the recommended sight distance values for the major road grade is generally needed because both the major and minor road vehicle will be on the same grade when departing from the intersection. However, if the minor road design vehicle is a heavy truck and the intersection is located near a sag vertical curve with grades over 3%, then an adjustment to extend the recommended sight distance based on the major road grade should be considered. Sight distance designed for left turns at divided highway intersections should consider multiple design vehicles and median width. If the design vehicle used to determine sight distance for a divided highway intersection is larger than the passenger car, then sight distances for left turns will need to be checked for the selected design vehicle for smaller design vehicles as well. So if you consider the design for trucks only, you should also check it for the provisions in the passenger cars. If the divided highway median is wide enough to store the design vehicle with a clearance to the through lanes of approximately 1 meter at both ends of the vehicle. No separate analysis for the departure site triangle for left turns is needed on the minor road approach for the near roadway to the left. In most cases, the departure site triangle for right turns, case B2, will provide sufficient sight distance for a passenger car to cross the near roadway to reach the median. Possible exceptions are addressed in discussion of case B3. If the design vehicle can be stored in the median width, adequate clearance to the through lanes, a departure site triangle to the right for left turns should be provided for the design vehicle turning left from the median roadway. Where the median is not wide enough to store design vehicle, a departure site triangle should be provided for that design vehicle to turn left from the minor road approach. The median width should be considered in determining the number of lanes to be crossed. The median width should be converted to equivalent lanes. That is, of course, if that median is already width wide enough, comparable to a lane of the highway. Example, a 7.2 median should be considered as 2 additional lanes to be crossed in applying the multi-lane adjustment time gaps in table 9-5. Remember, we have our adjustment. We add 0.5 seconds for passenger cars for an additional of 1 lane. So if the median, for example, in this portion is equal to 7.2 meters wide, then we will add an additional of 2 lanes in our time gaps consideration. Furthermore, a departure site triangle for left turns from the median roadway should be provided for the largest design vehicle that can be stored on the median roadway with adequate clearance to the through lanes. These are some additional considerations. You may just read on it. We will now move to case B sub 2 or B2. Right turn from the minor road. So basically, we will be considering this part. So this portion. So if this is the car, we will move to the right. For the right turn, we will need to have this one as our intersection side distance. Okay? A departure side triangle for traffic approaching from the left, like that shown in figure 9-15, should be provided for right turns from the minor road onto the major road. Intersection side distance for right turns is determined in the same manner as for case B1, so similar, except for the time gaps in table 9-5 should be adjusted. So we will add 1 seconds for the right turn maneuvers without undue interference with major road traffic. So field observations indicate that in making right turns, drivers generally accept gaps that are slightly shorter than those accepted in making left turns. The time gaps in 9.5 can be decreased by 1.0 seconds or 1 second for right turn maneuvers without undue interference with major road traffic. Because if you'll notice, for left turn here, for the left turn maneuver, you will require longer time. But for right turn, that is a shorter distance, meaning you will require lesser time to do the maneuver. So we will adjust it into these following values. That would be from 7.5 to 6.5, from 9.5 to 7 to 8.5, and from 11.5 to 10.5 for passenger, single unit, and combination design vehicle. Again, we will consider this for multi-lane highways, additional 0.5 per passenger and 0.7 for trucks. And an additional of 0.1 second per exceed per excess of the 3% grade. Sign values based on these adjusted time gaps are shown in table 9-8. So we have that for case B sub 2. And figure 9-18 includes the design values for the design vehicles for each of the time gaps in table 9-7. When the minimum recommended sight distance for a right turn maneuver cannot be provided even with the reduction of 1 second from the values in table 9-5, consideration should be given to installing regulatory speed signaling or other traffic control devices. If it does not meet the values in table 9-5, even if you reduce it by 1 second, we should provide our traffic control devices. These are for case 2, B2, and for case B3. For case B3, crossing maneuver from the minor road, meaning you will continue from this portion and you will cross straight. So you can use both of these. In most cases, the departure sight triangles for left and right turns onto the major road as described in cases B1 and B2 will also provide more than adequate sight distance for minor road vehicles to cross the major road. So these values are longer, are adequate in this consideration of case B3. Of course, because it is harder to maneuver to the left or to the right because you need to look at certain things also, or certain parts of the intersection. The following situations, it is advisable to check the availability of sight distance for crossing maneuvers where left or right turns or both are not permitted from a particular approach and the crossing maneuver is the only legal maneuver. Where the crossing vehicle would cross the equivalent width of more than 6 lanes, or where substantial volumes of vehicles, of heavy vehicles, cross the highway, and steep grades that might slow the vehicle while its back portion is still in the intersection are present on the departure roadway on the far side of the intersection. The equation for the ISD in case B1 is used again for the maneuvers. It's just that we are changing the values of time gaps, or we are using the values from table 9-7. 9-7 is this portion, similar with what we use in case B2. Okay, so continuing, at divided highway intersections, depending on the relative magnitudes of the median width and the length of the design vehicle, intersection sight distance may need to be considered for crossing both roadways of the divided highway or for crossing the near roadway only and stopping in the median before proceeding. Okay, so you may utilize the median if that is wide enough to stop at that portion before proceeding with the crossing maneuver. The application of adjustment factors for median width and grade is discussed under case P1. Table 9-8 shows the design values for passenger cars for the crossing maneuver based on the unadjusted time gaps in 9-7. Because we are using the same values for the time gaps, of course we will have the same values for case B2 and B3 for the ISD. Case C, intersections with yield control on the minor road. So if there is a yield sign in the minor road, this will be used. Drivers approaching yield signs are permitted to enter or cross the major road without stopping if there are no potentially conflicting vehicles on the major road. The sight distances needed by drivers on yield-controlled approaches exceed those for stop-controlled approaches. For four-leg intersections with yield control on the minor road, two separate pairs of approach sight triangles like those shown in figure 9-15A should be provided. So that is for approach side triangles. And one set of approach side triangles is needed to accommodate crossing the major road, and a separate set of side triangles is needed to accommodate left and right turns onto the major road. Both sets of side triangles should be checked for potential side obstructions. For tree-like intersections as shown in the figure, with yield control on the minor road, only the approach side triangles to accommodate left and right turn maneuvers need to be considered because the crossing maneuver does not exist. Okay? So we only consider the left and right turn maneuvers for this one, not the crossing maneuver for tree-like intersections. You have two cases for case C. Crossing maneuver from the minor road. The length of the leg of the approach side triangle along the minor road is to accommodate the crossing maneuver from a yield-controlled approach. Distance A sub 1 in figure 9-15A, similar to the previous figures, is given in table 9-9. Distance A sub 2 is longer than distance A sub 1, still the same with the previous discussions of approach side triangles. Table 9-9 are based on the same assumptions as those for case A, except that, based on field observations, minor road vehicles that do not stop are assumed to decelerate at 60% of the minor road design speed rather than 60%. So for this one, for case C sub 1, they are decreasing their design speed by 60%, comparing with the 50% for case A. So crossing maneuver, still C1. Sufficient travel time for the major road vehicle should be provided to allow the minor road vehicle to travel from the decision point to the intersection while decelerating at a rate of 1.5 seconds or meter per second squared, similar. So from this one, decision point crossing, that is, they are decreasing. To cross and clear the intersection at the same speed. The intersection side distance along the major road to accommodate the crossing maneuver, distance B in figure 9-15A, should be computed with the following equations. So for case C sub 1, we can compute the time gap using these formulas. So here, Tg is the travel time to reach and clear the major roads. B is the length of the side triangle along the major road, or this is also equal to ISD. U sub A is the travel time to reach the major road from the decision point for a vehicle that does not stop. Use appropriate value for the minor road design speed from figure 9-43 adjusted for each approach grade where appropriate. W is the width of the intersection to be crossed. LA is the length of the design vehicle, and V minor is design speed for minor road, and V major is the design speed for major road. So using this formula, that is just direct substitution, you can compute for the TG required. The value of TG should equal or exceed the appropriate travel time for crossing the major road for a stop from a stop controlled approach as shown in table 9-7. So these are the minimum values still from tables 9-7 for case B, from case B3 still. Okay, so these are the minimum values. So if you computed a value that is lesser than these values, you should use this one, and you will still need to adjust for these conditions for multi-lane highways and for minor road approach grades variations. The value of TG should equal or exceed the appropriate travel time for crossing the major road stop control approach. The design values for the time gap shown in table 9-9 incorporate these crossing times for two-lane highways and are used to develop the length of the leg of side triangle. So for table 9-9, you have this some notes. For minor road approach, grades that exceed 3% multiply the distance or the time in this table by the appropriate adjustment factor from table 9-4 and some other considerations. You can just read on this one. So here are the image comparing the stopping sight distance with the case C sub 1 crossing maneuvers. So the distances and times in table 9-9 should be adjusted for the grade of the minor road approach using table 9-4. And if the major road is divided highway with a median wide enough to store the designed vehicle for the crossing maneuver, then only crossing or the near lanes needs to be considered, and the departure site triangle for accelerating from a stop position in the median should be provided cases based on case B3. So that is similar to the previous discussions. Table 9-10. Here is the length of the site triangle along major road C sub 1 crossing maneuver at yield controlled intersections. So you have it here. Again, this is table 9-4 for your adjustment on grades. And we now move to case C2, left and right turn maneuvers. The length of the leg of the approach side triangle along the minor road to accommodate right turns without stopping, distance A sub 1 in figure 9-15A should be 25 meters. Okay, so that is the minimum. This distance is based on the assumption that drivers making left and right turns without stopping will slow to a turning speed of 16 meters per 16 kph. Distance A sub 2 for left turns is longer than distance A sub 1 for right turns, as defined in the discussion of approach site triangles. Again, this is equal to A sub 1. The leg of the approach side triangle along the major road, distance B, is similar to the major road leg of the departure side triangle for a stop controlled intersection in cases B1 and B2. Because this is yield controlled. In that case, you will have to stop. I'm sorry, I should have placed here departure. Anyway, they are similar. However, the time gaps in table 9-5 should be increased by 0.5 seconds to the value shown in 9-11. So here, this is table 9.5 for case B1. We will use these values now, increasing it by 0.5 automatically. For case 2, left or right turn, for yield considered, for yield control. Again, don't forget your adjustment values here for multi-lane highways and for the time gaps or case 2, C2. The appropriate lengths of the side triangle leg are shown in table 9-12 for passenger cars and figure 9-20 for general design vehicle categories. A minor road vehicle needs 3.5 seconds to travel from the decision point to the intersection. This represents additional travel time that is needed at a yield-controlled intersection but is not needed at a stop-controlled intersection. So for yield-controlled intersection, there is an additional 3.5 seconds for the maneuver. However, the acceleration time from entering the major road is 3 seconds less for a yield sign than for a stop sign because the turning vehicle accelerates from 16 kph rather than from a stop condition. Because that is a yield control, meaning it is not necessary to stop. the vehicle may just reduce its speed. The net 0.5 increase in travel time for the vehicle turning from a yield-controlled approach is the difference between the 3.5 seconds and the 3 seconds less increase in travel time and the 3-second reduction in travel time. That is why we are adding 0.5 seconds. This is table 9-12 for the decision ISD of case 2. Left or right turn at yield controlled intersections. And again, the figure showing or comparing it with the stopping sight distances provisions. Departure sight triangles, like those provided for stop-controlled approaches, cases B1, B2, and B3, should be provided for yield-controlled approaches to accommodate minor road vehicles that stop at the yield sign to avoid conflicts with major road vehicles. So remember, for case B, that is stop controlled. Case C is for yield control. For case 2, or case C, rather, you should still provide the provisions in the case B, because some vehicles will not yield or will not just reduce their speed. Some vehicles may stop, so they may use the values in case B. However, since approach sight triangles for turning maneuvers at yield-controlled approaches are larger than the departure sight triangles used at stop-controlled intersections, no specific check or departure sight triangles at yield-controlled intersections should be needed. Yield-controlled approaches generally need greater sight distance than stop-controlled approaches, especially at four-leg yield-controlled intersections, where the sight distance needs of the crossing maneuver should be considered. If the sight distance sufficient for yield control is not available, use of a stop sign instead of a yield sign should be considered. So if the sight distance sufficient for yield control is not available with the limits of the road conditions, then you will need to use a stop sign. Upgrade from a yield sign to a stop sign. Okay. In addition, at locations where the recommended sight distance cannot be provided, consideration should be given to installing regulatory speed signaling or other traffic control devices at the intersection on the major road to reduce the speeds of approaching vehicles. So this is where the part in which we provide our traffic control devices such as our traffic lights or traffic signal lights. We now move to case D, the intersections with traffic signal control. This is somewhat easier to use because we are controlling or guiding the vehicles to stop or to reduce their speed. So it is easier to use signal control. Of course, you use this for areas or intersections with more traffic volume. At signalized intersections, the first vehicle stopped on approach should be visible to the driver of the first vehicle stopped on each of the other approaches. So, for example, here, let's say that this is a stop control or traffic signal controlled intersection. Both of the cars here should be visible with each other. Left-turning vehicles should have sufficient sight distance to select gaps in oncoming traffic and complete left turns. Apart from these sight conditions, there are generally no other approach or departure sight triangles needed for signalized intersections. Signalization may be appropriate crash countermeasure. Yes, that is an appropriate crash countermeasure or accident countermeasure for higher volume intersections with restricted sight distances. As I've told you, if you will notice in the provisions of our figure 9-15 in the sight triangles, it will really require that at the corners or at the areas in which these sight triangles are provided, there should be no obstructions such as trees, buildings. So signalization is important if there are restrictions such as this one that have experienced a pattern of sight distance related crashes. So for this one, there is a building in this portion. It will block the view of the driver in approach site triangles. So we need to provide signalization. However, if the traffic signal is to be placed on a two-way flashing operation, flashing yellow on the major road approaches and flashing red on the minor road approaches under off-peak or nighttime conditions, then the appropriate departure site triangles for case B, both to the left or to the right, should be provided for the minor road approaches. So, yan, kapag flashing yellow, meaning, or flashing red, meaning you will need the yield or the stopping, stop control signs. Okay? In addition, if right turns on a red signal are to be permitted from any approach, then the appropriate departure site triangle to the left for case 2, B2 should be provided to accommodate right turns from that approach. So, usually at night time kasi, there are less traffic, or yeah. So, we use yung flashing yellow and flashing red for traffic signals. Meaning, the drivers are advised to proceed with caution. Case E is intersections with always stop control. At intersections with always stop control, the first stop vehicle on one approach should be advised visible to the drivers of the first stop vehicles on each of the other approaches. There are no other sight distance criteria applicable to intersections with always stop control, and indeed, always stop control may be best option at a limited number of intersections where sight distance for other control types cannot be attained. So we can use case B in this one for case E. Case B in all portions of the major or minor roads, because that is an always stop control intersection. Case F is for left turns from the major road or locations along a major highway from which vehicles are permitted to turn left across opposing traffic, including intersections and driveways, should have sufficient sight distance to accommodate the left turn maneuver. Left turning drivers need sufficient sight distance to decide when to turn left across the lanes used by opposing traffic. Sight distance design should be based on a left turn by a stopped vehicle, since a vehicle that turns left without stopping would need less sight distance. For case F, the sight distance along the major road to accommodate left turns in the distance traversed at the design speed of the major road in the travel time for the design vehicle given in table 9-13. So you will use this time gap instead. Again, you will use the formula ISD is equal to the conversion factor multiplied by the velocity of the major road times the time gap. The unadjusted time gap in table 9-13 for passenger cars was used to develop the sight distances in table 9-14 and illustrated in the figures 9-21. So this time gaps was used to develop this table for ISD in case F, and is illustrated in these figures for metric and US customary units in the comparison between the SSD and ISD for case F. So as a review of the concepts, the driver of a vehicle approaching an intersection should have an unobstructed view of the entire intersection, including any traffic control devices, and sufficient lengths along the intersecting highway to permit the driver to anticipate and avoid potential collisions. So that is why we provide the provision of traffic control signals or traffic control devices are important, and following these traffic control signals are also important, sufficient or supplementary to staying alert for in the point of view of the driver, because it will provide us with sufficient time to decide and to execute certain maneuvers that we want to do, and paying or giving our full attention to these traffic devices and to other road elements such as pedestrians and other vehicles will help us to prevent meeting accidents. Remember that accidents are unexpected, but they can be prevented. Okay? So that would be for this module. Thanks for watching. So the next part of this one would be we will be discussing about passing sight distances. Thank you.